In this part of the Computational Intelligence course, we will start to fuzzy set theory. You will learn how to extend classical set definition to fuzzy sets, what is fuzzy set membership function, what are the vertical and horizontal representation of fuzzy sets. By a set, we understand every collection made into a whole of definite, distinct objects of our intuition or of our thought. This definition is by Cantor. For a set in the Cantor sense, the following properties hold. An element X is not same as the set containing only that element. If X is element of the set X and that set X is element of set Y, then X is not element of set Y. The set of all subsets of X is denoted as 2 to the power X. This symbol is representing the empty set and thus very important. Now we are going to extend the definition of classical set into fuzzy sets. The linguistic description, all numbers smaller than 10. This is an objective description and it can be modeled by this membership function. And the membership function is such that if the value of X is less than 10, the membership has value 1. And if it is greater than 10, including the point 10 itself, then it has membership value 0. This is also called characteristic function of a set. Consider all numbers almost equal to 10. This is a subjective description. For this one, for example, membership function of a fuzzy set can be used. Here at point 10, because we are trying to represent almost equal to 10, the value of the membership function value is 1. And around it, as we are going far away from the point 10, the value of the function is decreasing. A fuzzy set mu of x is the reference set, which is not empty, is a function from the reference set x to the unit interval, that is, mu is a function from x to interval 0, 1. Fx represents the set of all fuzzy sets of x, that is, Fx is defined as mu values such that mu is from x to interval 0, 1. So any function satisfying this condition is a fuzzy set. So far, fuzzy sets were described by their characteristic function or membership function and assigning degree of membership mu x to each element x in the reference set. That is the vertical representation of the corresponding fuzzy set. For example, consider the linguistic expression like about m. The vertical representation can be, for example, this function. Here we have the parameter m. This is as given here, about m. And also another parameter is the value of the membership is 1 minus absolute value m minus x divided by d, when x is between m minus d and m plus d. The membership is 0 otherwise. This function can be shown as given here. M is the point where we are going to define about M. At that point, the value of the membership is 1, and it is going to 0 when x is m minus d. So between m minus d and m, the value is increasing from 0 to 1. And after that, up to m plus d, the value is decreasing to 0 from 1. Another linguistic expression, for example, approximately between b and c, can be represented by this function. Here we are desiring the value of the membership to be 1 between b and c, and to decrease to 0 as we get far away from b by decreasing the value of x. Meanwhile, the value of the membership is decreasing from 1 to 0 at point A. And similarly, at point D, the value of the membership is 0, and from C to D, it is decreasing from 1 to 0. And outside of this region, when x is less than A or greater than D, the value of the membership is equal to 0. These are the mathematical expression for this function in these different intervals. If x is between a and b, it is given by the function x minus a divided by b minus a. If x is between b and c in this region, the value is 1. And when x is between c and d in this region, the value of the membership is x minus d divided by c minus d. And at any point less than a here or greater than d, the value is 0. Another representation is very often applied as follows. For all membership degrees, alpha belonging to chosen subset of interval 0, 1. Human expert lists element of X that fulfill one concept of fuzzy set with degree greater than equal to alpha. That is the horizontal representation of fuzzy sets by their alpha cuts. Here is the definition for the alpha cut. Let mu be element of fuzzy sets on X and alpha be a value between 0 and 1. Then the alpha cut and strict alpha cut of mu are defined as. This is the alpha cut. It is written as in square parentheses mu membership function mu, and this is alpha cut. This is the points in X such that the membership value at those points are greater than or equal to alpha in the alpha cut. However, in the strict alpha cut, here we have the alpha is underlined. In that case, the definition is very similar to alpha cut. The only difference is that here in the alpha cut we have greater or equal to. In the strict alpha cut we have greater than. Let alpha be a value between 0 and 1, and A is a subset of X such that the membership for A is a function from X to interval 0, 1. And this is the indicator function or characteristic function. Here we have if x in the subset, the membership value is 1, and otherwise, if x is not belonging to A, the membership value is 0. For such a function, for which the membership value is either 1 or 0, then the alpha cut of the function is always equal to A when alpha is greater than 0, and it will be equal to x if alpha is equal to 0. This function xa is called indicator function or characteristic function of A. Another example, let mu be a triangular function on R as shown above. Here we have a reference set which is R. Here in the interval between A and B, the value of the membership is greater than 0, and outside of this region, when x is less than A or greater than B, the membership function has value 0. At M, the value of the function is 1. It is decreasing to 0 from M to A, and similarly from M to B, it is decreasing from 1 to 0. Alpha cut of mu can be constructed by 1. Drawing horizontal line parallel to x-axis through point 0 alpha. So here we have a line passing through alpha parallel to the x-axis. And then projecting this section onto x-axis. So here, if we consider the value of the membership, here from this point up to that point, the value is greater equal to alpha. Outside of this region, the value is less than alpha. We are projecting this section onto x-axis. So this is the alpha cut. If we write formally, if alpha is between 0 and 1, then alpha cut of the membership function given here, we have A plus alpha multiplied by m minus A. It is that point. From this point up to point B minus alpha multiplied by B minus M. And we are considering this interval. So this is the interval starting from this point up to that point. If alpha is between 0 and 1, if alpha is 0, then alpha cut will be whole real numbers. It is R itself.